Hi, grade 12s. Hope you're doing well. Hope you feel good after paper one. If not, don't stress, there's still paper two. And I hope your preparations for paper two is well underway. I thought I'd just make a quick video for you guys based on the fact that there were no graphs in paper one. And there's a strong likelihood that there will be a graph in paper two. Just giving you some reminders on what to look out for and what best way to prepare for it. And also, since the investigations in paper one were quite straightforward, um, maybe pointing out some things to look out for to make sure that you get good marks when it comes to the investigations. So, firstly, just going to go through this question from 2016 November because it's quite a nice question that showcases a lot of the pitfalls when it comes to investigations. So, firstly, when you read through an investigation question, the first thing to look out for is any sentence where they talk about there was an investigation. So, um, so over here it says the scientist investigated. Then you know that is going to be where you can get your independent and dependent variable from. So the scientist investigated, or an investigation was done, or sometimes they might talk about an hypothesis or some other way of stating it. But this is your indication of this is the aim of the investigation. So this is where I can get the variables from. Then in this example, they say scientists investigated the relationship between the color of lizards in a population and their survival rate on an island. So in here is going to be our two variables. So if we read carefully, we'll see that the color of lizards is a variable. And remember, a variable is something that can change. So the color of lizards is something that can change. So that is our variable. And the survival rate is our other variable. And again, survival rate is something that can change. You can have a higher survival rate or a lower survival rate. So in this case, those are our two variables. And we'll look just now at the questions and identify which is dependent, which is independent. But for now, I just wanted to show, first thing you do is highlight the two variables in this investigation. Then if we read through the rest of the question, they have quite a short method here. Oftentimes this will be longer, but in here there's also a few things to look out for. So they say they conducted the investigation as follows. They selected a group of lizards of a certain species in a habitat. Now, in there is also some key information because they tell you it's a certain species and in a habitat. They don't say a specific habitat, but we can assume based on how they phrase it here that it's within one specific habitat. Um, and this would indicate to us this is something that remained the same. They used one specific species in one specific habitat. It's not as clear in this investigation. Most of the time, they will make it a bit clearer. They would say the same species in the same habitat, but that's something to look out for. So whenever you see same or they just refer to something and you can see that it is the same between the investigations, then you know, okay, that is what they kept the same, which is also one of the questions that is oftentimes asked. Then they say they recorded the percentage of each color, brown, red, or black, in the selected group. So nothing specific there to highlight, but obviously still important information. And they repeated the investigation over a period of 30 generations. So that you should know is obviously very important to note as well. They repeated the investigation over 30 generations. So there is a lot of the most important information highlighted before we even looked at the questions. So we know that oftentimes they will ask questions about these type of things. So when you go through your question, highlight them. So when they do come up in the questions, you know they are important. Okay, so let's quickly look at the questions for this investigation. So the first question, state the independent and dependent variable. So we already earlier highlighted and identified our variables. So if we go back to the aim of the investigation, so this is our aim, this is where we will find the dependent and independent variable, not from the table. Very important. Do not go to the table to get your variables, because you'll see here that the variable that they give in the table is different than the variable that is mentioned in the aim. And that is because oftentimes in order to get data for the investigation, they have to measure variables in a certain way. And that is what you'll find in the table. But that is not the original dependent or independent variable. So the place to get the answers for this question is from the aim. Okay, so always go back to the aim if you are looking for the variables. So in this case, we highlighted the color of the lizards and the survival rate of the lizards as the variables. Now we need to determine what is the dependent and what is the independent variable. In this case, or what I always do is I ask myself which variable depends on the other one. And in this case, the survival rate of the lizard depends on the color of the lizard. So that is going to be our dependent variable, the survival rate of the lizards, which makes the color of the lizards the independent variable. Okay, so yeah, by variables, independent variable is the color of the lizard, and dependent variable is the survival rate of the lizards. Something to also just keep in mind is that sometimes in the aim, the variable is a bit obscure and it isn't necessarily something that you can easily measure, or something that easily or that you can see how it changes. So the wording of the variable is sometimes a bit strange, and then you have to reword it slightly. This example, not so much, but I'll see if I can find an example where you can see that is the dependent variable, but you just have to phrase it a bit differently. Okay, but in this case, it's straightforward. It's the color of the lizards and the survival rate of the lizards. Then the next question is a evolution question. So I'm not going to answer that one now. It is in the question bank, so if you're looking for the answer for that one, you can find it there. I want to focus on the questions about investigations. So the next one, explain why the scientist had to conduct this investigation over 30 generations. So hopefully you can immediately see that this is a question about reliability, because they're talking about multiple generations. So the investigation was conducted over a long period of time. But what you would notice is that this is a 2-mark question. So you can't just say to ensure reliability. You have to explain why the 30 generations would ensure reliability. And in this case, if you think about the investigation, if you are doing an investigation to see how the color changes over time, so the survival rate of different lizards changes over time, you need to do it over multiple generations, because otherwise you might not see the change. You might not see a change after one generation, you might only see a change after many generations. So that would be the explanation here. So you have to say that they conducted it over 30 generations to allow enough time for reproduction to take place, so that you can see the change in the population over time to ensure the reliability. Okay, so I'm going to show you the memo for this question. Um, So they had to allow enough time for reproduction and survival to be able to be calculated, or to calculate the percentage to ensure reliability. Okay, so enough time for reproduction to ensure reliability. Okay, so that's the 2 marks for this question. Or you could have said a change in population proportions will only be seen or will not be seen over a short period of time, and then to ensure reliability. Okay, so that first mark is just for explaining in this specific context why it was necessary. And then the second mark is for the reliability. Now, this is not the only way that reliability questions can be asked. So In fact, most of the time they will ask it the other way around. So let's quickly talk about that. If they ask, how did the scientist ensure reliability? Then you go back to your investigation and then you go look for something about the investigation being repeated over many generations in this case, or for a large sample size. Um, so if they said they used 150 lizards, then you know that, okay, that is to ensure reliability. Okay, so you always look for um, somewhere where it says they repeated the investigation or they used a large sample size. But don't just say they repeated it or they used a large sample size. Be specific. So in this case, say they repeated the investigation for 30 generations. Okay, be specific in your answer because oftentimes they want that specific number. Okay, so they repeated the investigation over 30 generations. Or if they mentioned here about the number of lizards they used, then you could have said they used a large sample size of 150 lizards. Okay, and then a third way in which they can ask about reliability is what should they have done to ensure reliability? Okay, so they could ask what did they do or what should they have done? So in this case, if they ask what should they have done, then you have to go look for what did they not do. So in this case, they mentioned that they repeated the investigation, so you can't say that, but you can say that they should use a large sample size of lizards, okay, or they should use many lizards of each color. And that is something that they could have done to ensure reliability. Then the next question has to do, or next question, state two ways in which scientists could have improved the validity of the investigation. So this is the next type of question that you oftentimes get, having to do with validity. And in this case, they ask what could they have done? So not what did they already do, what could they have done? Okay, so again, for this, we'll have to go back to the investigation and we have to see what could they have done. So let's first see what did they do. And we highlighted that earlier. We said that they used a certain species and then in a habitat, but they don't specify that it's a specific habitat. So we'll get back to that now. But one thing they definitely did is they used a specific or a certain species. So if the question was, what did they do? Then you could have said they used the same species for each color of lizard. Okay, that is something that they did do. But now what could they have done? So we can't talk about species because they've already done that. But something that they could have done is they could have ensured that each species was tested in the same habitat. Okay, remember when you're talking about validity, you're looking for things that must have remained the same to make sure that the investigation was fair for each of the colors of lizards in this case, or for each group that was tested or each plant that was tested. You want to look for things that should be the same to make it fair. The only thing that is allowed to change in an investigation is the independent variable. So in this case, the color of lizards is the only thing that should change. Everything else should be the same. So we should use the same species and we should use the same habitat. So that can be our first answer, the same habitat. But now something else, so now we need to find another thing that could remain the same. And if you read through this investigation, you don't really see anything obvious. Some of the obvious things that oftentimes can remain the same is the age and the gender um, and the type of plant and things like that. But in this case, there isn't anything obvious that jumps out. So this is where you'll have to think outside of the box a bit. And in this case, something that could remain the same to ensure the reliability is the number of lizards that you use for each color. Because if you think about it, you can't use 100 brown lizards and only 10 red lizards. Okay, that's not fair. And we do see that there's a bit of an issue here in their investigation in that regard. But that is something that should actually be the same. So the same number of lizards for each color. And then other answers gets a bit more into the specifics of this question and is actually quite a bit tricky. But some other things that could remain the same is the sampling technique they used to determine the number of lizards. So that's something that they could remain the same. And then the last thing is to take the sample of lizards at the same time of the day. And then they also mention weather conditions for each lizard. So that kind of ties in with habitat, but the same weather conditions. Um, yeah, I don't quite see it in this case, but that's also environmental conditions is also something that's oftentimes one of the answers that you can go to. The same environmental conditions, but be specific. Don't just say environmental conditions or weather conditions. Say the same temperature or the same humidity or the same rainfall. But yeah, in this case, I would have avoided that because it isn't as clear how that will affect things. Always make sure that the variable you give is very clear. How will this affect the investigation if it's not the same? Okay, so if it's not an obvious effect, then oftentimes it won't be on the memo. So you're not necessarily going to get your marks for that. Okay, try and go for the most obvious variables. Okay, but the most important thing here, when they ask about validity, it's what should remain the same or what did remain the same, depending on the question. Okay, then the next question is another evolution question. We're going to skip that one. And then the last question asks you to draw a graph, okay, which is obviously why I'm making this video. So what I want to show you here is some of the things that you get wrong when you draw graphs. Okay, so firstly, most of the time they tell you what type of graph to draw. Make sure you draw that type of graph because that's 1 mark. Okay, so a bar graph. Okay, so don't draw anything else, draw a bar graph. And then they say, draw a bar graph to compare the percentage of brown and black lizards in the initial population and the 30th generation. Okay, so they want very specific information in this graph. They only want the brown and black lizards, and they only want the initial population and the 30th generation. So if we go look here at our table, they want the brown lizard, the black lizard in the initial population and the 30th generation. So you must ignore everything else. You must ignore the red lizard and you must ignore the 10th and 20th generation. If you don't and you put everything on your graph, you are going to lose marks. Okay, so very important. Then the next thing to note when you are drawing a graph, and I'm going to show you this before we go over to the memo, is that in a graph, you use the variables in the table. So you don't use the variables from the AIM like we did earlier. You have to use the variables in the table. And that's normally quite simple. It's normally at the top of the table. Okay, so your color of your lizards and the percentage of each color in the population. Okay, so just like that, exactly like it is in the table, that is what you're going to use in your graph. Okay, when we move over now to the graph, you'll see that. Okay, but before we do that, something you should also know is which variable goes on which axis. And your dependent variable always goes on your y-axis, so that would be the percentage, and your independent variable always goes on your x-axis, so that would be the color of the lizards. Okay, so this is going to go on your x-axis, and then the percentage of the initial and the 30th population, that has to go on your y-axis. Okay, I'm going to move over to the memo so I can point out some of the things that you must look out for and you must do when drawing graphs to make sure that you get your marks. Okay, so in this case, there were two ways in which you could actually draw this graph, because you have to draw a double bar graph to show the initial and 30th generation, as well as the brown and black lizards. So in order to do that, you need to draw a double bar graph like this, or like this, where you have the brown and black lizards, and then you show the initial and 30th generation with a key. Okay, so either one is fine. So they made provision for both. Okay, but let's just look at one of them. So here we've got our generation, or in the second example, the color of the lizards on the x-axis. Actually, let's look at the second one because that's the way most people would draw it. Okay, so the color of lizards on the x-axis and the percentage of the population on the y-axis. Then places where people lose marks is for the heading because they don't put the right information in the heading. So you have to say the comparison of the percentage of brown and black lizards. So the percentage of lizards, not the survival rate of the lizards, the percentage of lizards in the initial and 30th generation. So you see here that they do not talk about the survival rate or the color of the lizards. They mention the color, but they use specifically the axis. So whatever's on your axis must go in your heading. Okay, very important. Okay, so this is where it differs from the question on independent and dependent variable. Okay, when it comes to graphs, you have to use the information from the table. Okay, so whatever you put on your axis is what you're going to put in your heading. Okay, so a lot of people lose this mark. Also, they lose this mark if they don't give enough information. Okay, so you have to say the initial and 30th generation. You can't just say the percentage, okay, for the different colors, okay, because then you don't specify what generations were used in this case. Okay, so that's one area where learners lose marks. Then there's always a mark for the type of graph, so make sure you draw this correct type of graph. Then something they don't show here, but it's oftentimes they give a mark for the scale. And where you lose marks here is if your bars are not the correct width or not the same width. So each bar must be the same width. Okay, so 1 centimeter or 2 centimeters or whatever it is, but they have to be the same width each bar. And also the spaces between the bars has to be the same. So in this case, because it's a double bar graph, you have a small space between the brown lizards and the black lizards, and then a big space between the two. But regardless, is those spaces have to be the same. Okay, so that's one area where learners lose marks. And then lastly is on their y-axis, if you just jump around, okay, you go 0, 10, 20, 40, 80, 100. So there's no consistency with your numbers here. Okay, then you will lose the mark there for scale as well. Okay, but that's something we've harped on a lot. So hopefully you know that by now. And then lastly, plotting. So there's always 2 marks for plotting, and 1 mark if you get at least one thing right, and 2 marks if you get all of them right. And it has to be exactly right. So if it's slightly off, then you lose that second mark. And since you get 1 mark for at least having some of it right, markers are very strict on that second mark. So you have to get it absolutely perfect to get that second mark. Okay, so watch out for that so that you can ensure that you get your 6 marks for the graph. Okay, I hope that was helpful. It was a very long, drawn out explanation, but I think I focused on a lot of the common questions. There's obviously some others as well about control groups, etc. So have a look at the other type of questions as well, but those are some of the most common questions that's where where you oftentimes lose your marks. So good luck for the rest. And yeah, I hope that paper 2 is as good as paper 1 was.